your state space schema already in your assignment. So what actually suggested to you in the Google Classroom is for you to proceed with Cartesian product. Okay, so where you put power set and then you put Cartesian product, right? Okay, so when you do your Cartesian product, of course, when you put power set, it will tell you many records. Okay, you will have many records. But the main problem with Cartesian product is actually you cannot see the relationship there, meaning that is it going to be many-to-many relationship, one-to-one relationship, or what? It will show only you will have many records, that's all. Okay? So that's why you put power set, then you put Cartesian product. So when you go for Cartesian product, in order for us to do our Z schema, that is not the best solution actually. But it is a starting for you to know that in your Z schema, there is a relationship between this data and this data. That's all. Okay, so that is the starting point. That's why for your assignment, we will start with Cartesian product first, so that you know that you are going to have a relationship between this and this. That's all. But you don't really care about the real relationship here in terms of is it going to be one-to-one, many-to-many, or what? You don't care about that yet. Okay, so in order for us to proceed with whatever that we have done previously, okay, now in this topic relation, we are going to change whatever that you have done, okay, your Cartesian product there, to show the relationship either many-to-many or one-to-one or whatever. Okay, from here, you have to update your state space schema to update your Cartesian product to cover either relation or later will be function. Okay, so that is actually, so because relation and function are actually the origin, not the origin, means that the one that we really use in our Z schema to represent our data. Okay, Cartesian product, whatever that you learn Cartesian product, we will use later for you to actually display in your operation schema, for example, to display record. Let's say you want to combine from your friend, some information from your friends, some information from your database, some information from another friend. So you extract some information here, extract some information here, some information here. So how to combine the whole information into one, then this is where your Cartesian product is needed. So you don't care whether it is many-to-many relationship or one-to-one relationship, you don't care about that. Just that you extract information only. So that is where your Cartesian product will be used later in your operation schema, especially for example, you want to display report, whatever, sales report, whatever. So normally we are going to use Cartesian product. But in our other operations, for example, to manipulate data, add, remove, whatever, okay, rather than we go for Cartesian product, we are going to go for either relation or function, because this one will show you how many records or how is your relationship of data inside your document there. Okay, so it's either like I told you just many-to-many or one-to-one or whatever. Okay, so now let's go to relation. Okay, so relation. Okay, so relation is actually to represent many-to-many relationship. So remember, I told you it's okay not to resolve your ER diagram, but sometimes, okay, it's okay to resolve it. Okay, it's up to how you want to handle it. But if you don't want to resolve it, we have many-to-many relationship symbol to represent inside your Z schema there. Okay, so we call this as binary relation, or I just name it as relation only. So normally when we talk about relation, okay, it's actually pairs, means two data, two columns, okay, two columns only, pairs of data. Okay, so when we go for relation, it's many-to-many. So you can have, okay, in this lecture slide, I will put name and phone, meaning that one person can have more than one phone number. For example, Normally, the easiest is for you to for me to give example in the office. For example, the office staff, okay, they can have land phone number, right? Okay, means office phone, and also they will have their own handphone number. So one person can have more than one phone number. Okay, and one phone number, especially office phone, can be accessed by a few staff inside the room, for example. So when you have this kind of scenario, then you can actually show this using many-to-many relationship by using binary relation symbol. Okay, so binary relation symbol, okay, is actually double-sided arrow. So when you convert, before this, right, you have done a Cartesian product with power set. So when you go for binary relation, okay, you just exchange, okay, the x Cartesian product with double-sided arrow. Another thing that you have to remember when you go for relation, because this relation is actually to show many to many, whatever, it's already many records and so on, you don't need to show power set anymore. Okay, you have to remove power set symbol. Okay, so you don't need to put power set. So it means that from here, okay, rather than you have power set, for relation, you don't have power set anymore. Just remove power set and then remove the bracket from your Cartesian product, remove the Cartesian product symbol, and then replace the Cartesian product with double-sided arrow. Okay, so that is what we call as relation. Okay, relation. So remember, when you go for relation, you don't need power set anymore. Okay, because this one will show many already. Okay, will show many records, so you don't need to put power set anymore. But if you go for Cartesian product, you have to put power set, because Cartesian product, if you don't have power set, it shows on the single record. Okay, but when it comes to when it comes to relation, it's okay, or you don't have to put power set anymore. Okay, because already shows many records. Okay, already shows many records. Okay, so if let's say we are talking about pair of object, means normally in your normal coordinates, right? You put bracket, comma, bracket, right? So that is a normal coordinate. How you have two x and y, so you put x and y, so you separate by comma. Okay, it's a normal what we did in our coordinates and so on. But when we do for Z schema, we are going to replace the comma symbol by what we call as maplet notation. Okay, this arrow. Okay, this arrow is another symbol that you have to remember. So this is maplet notation. Maplet notation, okay, is used for data representation only. Okay, when I say data representation, you cannot use maplet notation inside variable declaration. Okay, so this one just now, this is your type for variable declaration. Right, when you declare your variable, you put, let's say, phone, colon, then you put name, relation to phone. So that is variable declaration. So for variable declaration, you can use relation symbol. But when it comes to maplet notation, okay, maplet notation, you are talking about the data inside your database already. When you talk about data in your database, you don't use relation symbol anymore. You show relationship by using maplet notation. So maplet notation, the arrow will be like this. You have arrow here and then you have line here. Okay, don't get confused with the relation symbol with double-sided arrow just now. Okay, so for maplet notation, later you will see a lot that you have to use inside your predicate part. Okay, especially in your operation schema. Okay, in the predicate part, inside your operation schema. So rather than we use arrow, we are going to use maplet notation. So what do you mean by maplet notation? We are telling that in terms of this example, Eric, okay, means that have a relationship with Susie. If you put Susie in front, Eric after that, there are two different record already. So you cannot interchange each other. So if let's say you have Susie, Eric, and Eric, Susie, these are two different record already. Means that the domain is different, the range is different. Okay, so two different records. So when in our Z schema, if you want to show the records, your data inside the records there, you have to use maplet notation. Okay, so this is the symbol of maplet notation. Okay, so now, okay, when you do your variable declaration, so this is the example just now, name relation to phone. Okay, so this is actually what it means by when you declare your variable, something like this. So in your records, in your tables or whatever inside your database there, it shows two columns. Okay, the first column will be name, second column will be phone. Okay, it shows many to many because in this case, for example, okay, let's say I have Frank here, maybe it's Philip, sorry. Philip here, the name appeared twice, but you may have two different Philips inside your record there. And then for phone number here, I have 1107, for example, extension here. This is another extension 1107. Okay, so 1107 here can be accessed by one Philip here. Another 1107 here can be accessed by N here. And then, for example, Philip here is actually maybe different department, and Philip here may be another department, for example. So this is what we say as many-to-many relationship. Okay, means that you can have, okay, the domain, okay, one domain, because in your database, in your actual, if you draw a set, okay, Philips will not duplicate. This one I show in terms of table. You understand or not? When in your set, right, in your set, when you put curly braces, for example, let me use Microsoft Word, okay, when you go for the Microsoft Word set, okay, normally you will write like this. What is the name just now? Philip, and whatever lah, Mike, and so on. Okay, you are not going to duplicate Philip. The record will be individual in set. Okay, and then maybe your phone number just now, what? 234, whatever lah. 1107. Just now I remember 1107 only, Then you have extension, something like this, Okay, for example. And so on. Okay, in your set, the data will look like this. But in your actual record, maybe you have a relationship, you want to add record right into your database. Okay, you want to see that, okay, Philip exists or not? Yes, Philip exists. But for phone number 1107, let's say, in your actual database just now, you have, maybe you have already Philip. For example, the spelling, I follow this one. So you have maplet. This is a maplet. Okay, this one. When you see under relation here, this is a maplet notation. Okay. Okay, maybe you have 1107. Okay, in your database, you enter the data. Okay, the name of the staff is Philip. The extension is 1107. Then you enter another record, maybe Mike, for example. Then Mike also inside the same room, so the extension also 1107. Okay, 1107. Okay, inside the same room. Then you add another record. In your database, there is another person called Philip also, but different department, different room. So you add this record. Okay? Maybe the extension is 4566. Something like this. So in your record database, it will show like this. But the actual data as a set, there will be no duplication of Philip no duplication of 1107. You understand or not? Okay, but in your database, when you enter the data, you can have this kind of records. This kind of record. Okay, so that's what you mean by when you do maplet notation, your relationship. Okay, your relationship. So what I mean by this is one column. Okay, this is one column of record where you cannot duplicate. Okay, then this is another column of record that you cannot duplicate. But when you combine as a relationship, okay, using relation, okay, then when you enter the data later, you can check the record whether exists or not exists. But if it is a many-to-many relationship, it's a little bit different, because if you check Philip exists or not, of course now Philip exists. So you have to check both record exist or not in your database before you can add the records into the new records into your database. So later you will see how to do this also in your database. Okay, so this is example when you enter. So the table that I show you is like this. Okay, for example, that you want to show the table inside your data, how you enter the table, how you enter the data, so you can duplicate the data. Okay, so means that you will have something like this. So that's why in your here you can have, okay, for example, Philip here, this one, Philip here is different Philip from different department, for example, different room and so on. Okay, and then 110 here, maybe this one and this one are inside the same room. Okay, so that is what we mean by relation, many to many relationship. So you can have many records already. Okay, you have many records here, but it is many to many because in this case, Philip can have two Philips with two different phone number, two different Philip lah. And then one phone number can be accessed by many staff in this table. Okay, so in order for you to write this, if let's say you want to write this using maplet notation, so you just use like this. Okay, so you don't need to put bracket. Okay, just put curly braces. Then you put the relationship of friend to 1019, Philip 11707, and so on. So this is how you write down the record lah. So this one is by showing the table, but this one is actually how you show inside your Z schema. Record lah. Okay, record in your Z schema. Okay, so this is another example. For example, appointments here. Okay, one day can have many person or many patient for appointments, for example. And then one person, sometimes in the hospital, let's say you go to hospital, one person, you have different departments, right? One appointment for this department, one appointment for another appointment. So inside the, I would say as a record there, you have 2 or 3 different dates already. So this date is for this appointment, this date is for this appointment, this date is for this appointment. So it is a many-to-many relationship. Then you can show something like this. Okay, it is a many. So you have to ask yourself whether you are going to have many-to-many relationship or not. Okay, so you can have something like this. You can have something like this. So this is another relation that you can actually look into your assignment later. Okay, so this is another example. Okay, so just put you relation, so double-sided. Remember, the symbol for relation is this double-sided arrow. Okay, double-sided arrow. So for example here, birthday, you can have same person, a different person, but here actually later you will see for your assignment, I will suggest you to change. Okay, there are, when you do relation, sometimes you have to ask, okay, my system will not be good to have many-to-many. So then this is where you have to improve your assignment to become better. So when it becomes better, then you have to choose another symbol that you will see later under function. Okay? So, in the relation, there are a few things that you have to know. Okay? So first one is actually first and second keyword. This is keyword. First and second are keywords that you can use. Okay? But normally first and second are not popular to be used with our Z schema because it is only for one record. It is only for one record. Okay, so normally we didn't use first and second. First means first data from your record. Second is the second data from your record. Okay, that's all. So one record only, first and second. Understand or not? So it means one record, what is the first one? It means that the first coordinate, second coordinate, something like that. So that is first and second. But we are not going to use first and second in our Z schema because you will use a lot of what we call as domain and range. Okay, so when we talk about domain and range, it's similar like first and second, similar. Just that first and second, one record only, one single record. But domain and range, you are looking at all the records that you are going to have inside your database. All the records. So when you talk about the first coordinate, all the first coordinates there. When you are looking at the second coordinate, you are looking at all second coordinates. So that is what we call as domain and range. Okay, domain is for the first coordinates. Okay, whereas range is for the second coordinates. So that's why normally in Z schema, we are going to go for pair of records just now. At least two. Okay, so because easier for you to assess, or either you want to go for domain or you are talking about range data. Okay, so when you are looking at your data in your Z schema, you are not going to look at one record only. You are going to look at many records, either domain or range data. When you want to check for specific ID, for example, you are not going to check for one row only. You are going to check at all the rows, all the records that you have inside your database. So you have to check at everything there. So that is where you are going to use a lot of domain and range data. Okay? So domain, we are going to use DOM, and then range, we are going to use RAND. So when you talk about DOM, you are looking at 1, 2, 3 here. The first records, the first coordinates. Okay, means that all the records that you have, but the domain of first coordinates record. Whereas if you go for range, okay, you are looking at the second coordinates. Okay, second components. So A, B, C in this case. Okay, so when you want to write the data, okay, you just write in terms of either domain or range data only inside the braces, because this is still a set. Okay, so this is still a set. So if the data are duplicated, like just now, phone number of Philip, your result here, you don't have to duplicate because the end result will be a set. So when it is a set, don't duplicate the data. For example, if let's say you are talking about this, right? Okay? If let's say I talk about domain, okay, domain of your phone number here, dumb phone, if let's say I go for dumb phone, the answer will be Frank, Philip, Doc, and Mike, and change, without another Philip as the answer, the last one. Understand or not? Don't duplicate the answer inside your curly braces. You understand what I mean by this? Okay? Do you understand or not? I put down here, can see or not? For example, I put down phone. If I put down phone, can see or not? Or you want me to make it bigger? Okay? So if I put down phone, the answer will be here, Frank, Philip, Doc, and Mike, and James. Okay? Because the last answer will be a set. When it is a set, you don't duplicate Philip inside your answer. Okay? It is a set. If you put ran, fail, why I use phone here? Because this is my variable phone here. Okay, I use phone because my variable is phone. So the answer will be 1019 1107 2136 3110 2300 and 2140. Okay, so that's how you write the answer. Okay, don't duplicate the result. Okay, don't duplicate the result when you produce the answer. Okay, so in this case, just now 1107 have 2 times, right? So you don't need to type 1107 again because the end result will be as a set. Okay, as a set. So that's how you actually write down the answer for this one. Okay, if you are being asked by Dom or as Dom or Ren. Okay? Okay. So this is another example of what I said just now. For this one, right? 1, 1, 1, 2, 2, 2 here. So 1, 1, no need to duplicate 1. 2, only 1 for domain. So this one same thing. Don't duplicate the data. Okay, because the end result will be the set. Okay, will be a set. So you don't duplicate the data inside a set. Okay? So that is actually domain and range. Okay, source and target is not a keyword. Okay, both here are not the keywords. So source and target is just to tell you when we talk about source, actually we are talking about the domain. When we are talking about source, we are talking about the domain data. When we are talking about target, we are talking about the range data. But these two are not keywords. Okay, these two are not keywords. Compared to first, second, and domain range, those are keywords. And not domain range. Domain range is DOM and RAN. First and second keyword, domain range, DOM and RAN are the keywords. Source and target, both are not the keywords. These are just to let you know that sometimes the question will ask you what is the source of this. So the source means that the first coordinates, all the first coordinates. Target means all the second coordinates. Okay, that's what I mean by that. So the term here, source and targets, will actually looking at either first coordinates or second coordinate. But source and target, remember, are not keyword. Okay, don't just use the word source and target inside your operation later because these two are not the keyword. Okay, it's just to tell you either you are talking about the first coordinates or the second coordinates. Okay? Okay. So, operators, so before this, you have looked at union, intersection, backslash, whatever you have done this. I hope that you know how to use union, how to use backslash, union for add, backslash for remove, and so on, and then cardinality or hashtag. Okay, so you can still use this with your relation data. Okay, you can use this with your relation data if you want to use union, intersection, or actually backslash for removing, or hashtag. Okay, whatever that you have learned previously, you can still use with your relation. But if you want to do union, okay, you will see that I have two, right? Two data here, a pair of data. So when you want to use union, you have to union as a pair also. Okay, you cannot have union domain only. No, you have to union the data as pair of record also. So in this case, I have 1A, 2B, 2B, 3C, 2B already duplicate here. Okay, so you see your system. Either it is going to be no duplication or not You will see later. But if you can have duplication, then you can have actually 2B also. Okay, so you'll see this one is just for you to know that when you go from many to many or many to one, whatever, then your answer will be different already. Okay, but for now, we will say that you can do, here is just an example, you can do union and so on. Intersection you can do, backslash is removing and so on. When you do backslash, if it is 2 records, then normally you are going to do as a pair of record also. And then even the hashtag cardinality, okay, it will not calculate as 2 to 2, it will calculate as 1 record, 1 record, 1 record. So even though you have pair of data there, so it will calculate as 1 row, 2 row, 3 row, 4 rows and so on. So in terms of that, it will give you, let's say you have 3 records, 3 rows, the answer will be 3. Okay, it will not give you 1, 2, 3, 4, 5, 6. No, it will give you as 3 records only. Okay, so in terms of how many rows of record that you have in your database, if you use cardinality, it will give you in terms of that rows, how many records. Okay, so that is cardinality. Okay, so another symbols that you are going to learn also today will be what we call as domain restriction operator. Okay, domain restriction operator. So domain restriction operator is something like you want to search the data. Searching, you want to search data. That's why some of you say, can I do searching, whatever? Yes, you can. So later when you want to do searching, you are going to search either domain data or range data. Okay, so let's say you have one data, you want to search from the domain, from the first coordinates. You are searching from the first coordinates. We call this as domain restriction. Okay, you restrict your searching for your domain data only. Okay, so you are looking at the domain data, you search the record from the domain, then you display, you found the record, you display the records of that domain. Okay, so the symbol that you are going to use will be domain restriction operator. Okay, the arrowhead only pointing to the left. Okay, arrowhead pointing to the left. We call this as domain restriction. Okay, pointing to the left. So, assuming that these are your data inside database. Okay, so when you point to the left, meaning that you are looking at the domain. Okay, you are looking at the domain because domain is, if you are talking about table there, first column is domain, second column is range, first column is on the left. Okay, and second column is on the right lah. So that's why your arrowhead will pointing to the left. Okay, to the left. So on the left side here is must be your domain data that you want to search. Your domain data that you want to search.